In this video, you'll learn about relative frequency tables. First, let's talk about what a relative frequency actually is. This table will contain fractions, decimals, or percentages based on either the total of the overall data or the total of an individual category in a particular row or column. In this example, we need to complete this frequency table before we even think about relative frequency. Notice that some of the totals are missing, so I'll just add and subtract and fill in the missing figures. Remember, we're going to base this relative frequency table on the total overall data. So we'll make this table by dividing every number in the data category by the overall total, in this case, by the number 50. Nine divided by 50, 4 divided by 50, 10 divided by 50, and notice that I'm including the fraction that represents that division. 11 divided by 50, 1 divided by 50, and 15 divided by 50. Also look carefully. I'm not filling any of the totals yet. I'm going to leave that to the very end, and I'll tell you why in a minute. So simply put the division problems in your calculator. 9 divided by 50 is 0.18, 4 divided by 50 is 0.08, 10 divided by 50, 0.20, etc. Now let's review how do we change decimals to percentages. Because remember, a relative frequency table can contain fractions, decimals, or percents. Here we're doing all three. In order to change a decimal to a percent, you'll simply move the decimal place over 2 places to the right. For example, 0.25 would be 25%, and 0.9 would be 90%, etc. So let's go to our table and change all of our percentages as we just talked about. Now, let's add up our decimals and our percentages. One of the things we need to make sure we're careful of is that at the very end, everything adds up to 100%. That means we haven't made any mistakes or missed any of our data. Looks like this is going to work out well. Our percentages add up to 100%. Let's look at this next example. You go to a dance and you clean up afterwards, and to help you collect the soda cans. Some cans are organized on a table and some are in the garbage. So let's go ahead and complete the two-way frequency table from the values in this problem. And I've color-coded each of these for you. So there are 72 total cans in blue, 42 total cans in the garbage, 14 cans of Sprite on the table, and 50 total Coke cans. Now, just like in the last example, I'll work backwards to fill in my missing figures. Now we'll move on to divide every number in the frequency table by the overall total. In this case, the overall total is 72. We're going to write our relative frequencies as fractions and as percentages. So I've shown all the work here so you can see the mathematics behind our percentages. Notice that our overall total adds up to 100% as it should. The next thing I want to talk about is a two-way relative frequency table. So what's the difference between this and the relative frequency tables we just did? A two-way relative frequency table will divide table values by either a row or a column total, not the overall total. If we look at this example about utility vehicles and sports cars, you can see that I'm not even going to look at the overall total. I'm either going to look at the total of the rows or the total of the columns. 50 students in my class made choices of what type of toppings they would like on their ice cream and what flavors of ice cream. Notice I have automatically crossed off the total in the frequency table, and I am just using the totals of the choice of ice cream, vanilla or chocolate. In the first row, I'm dividing every number by 30. And in the second row, I'm dividing every number by the total chocolate, which is 20. This time, the total of each row needs to add up to 100%. That way, I know I've accounted for the total vanilla and the total chocolate individually. And it does. So we know we've had all of our data and we've rounded correctly. Now, let's make the relative two-way table of this and only look at the total of each column. So for sprinkles, I'll divide everything by 16. For the M&M column, I'll divide everything by 17. And for no sprinkles, I'll divide everything by 17 as well. Just like in the previous example, I need to make sure that this time each column adds up to 100%. Looks good. In the Park City School District, we'll have extra swim lessons in gym class if students can't swim by the 7th, 8th, or 9th grade. You're going to go through this frequency table and complete the missing numbers. Then you'll use that data to compute your relative frequencies based on the question you see on your notes and your Ed puzzle. Good luck!